This is the third part of our lesson on section 6.5. We're going to use theorem 6.7. In this diagram, angle QPR, that's this one, is congruent to angle RPS. That's this angle. Okay, so those two angles are congruent. Use the given side lengths to find the length of segment RS. So we want to figure out how long this is. So this problem is just like a problem you would do using this theorem 6.7. So remember we said A to B equals C to D. So we're going to use that same proportion here. We'll call this A, call this B, this will be C, and this will be D. Since this ray or segment bisected this angle, we know this proportion is true. Now, the problem with this is we don't know what A is, and we don't know what C is. We know that B is 7. We know that D is 13. Now, this whole entire length here is 15. So if we would just pretend for a second that this was 8, wouldn't it make sense that this was 7? If this is 8, how do you know that's 7? You subtract. Well, same concept. This C, the thing in the C position is really X. So it isn't 8, it's X. Well, what's this then? It's 15 minus whatever X is, right? If this was 8, 15 minus 8 would give you 7. 15 minus 8 would give you 7. So you don't want to use multiple variables, obviously. If this is X, this is going to be 15 minus that because the whole thing's 15. Here's a proportion that we're going to solve. 7 times X equals 13 times the quantity 15 minus X. 13 times 15. You can use your calculator for that. It'll give you 195. And you have to distribute the 13 over the X as well. We're going to add 13X to both sides. And then we'll divide by 20. And we'll get 9.75. And you can double check your work. If this is 9.75, then this would be 15 minus 9.75, which would be 5.25. And you could double check up here too. 5.25 to 7 better be equal to 9.75 compared with 13. Multiply those and multiply these. They should equal the same exact thing. That's how you know your answer is right. Here's two examples also. Yeah, this is just 16. Not sure why that came out like that. This is 15. This is 18. We want to find this length. Now, these are all right angles. These are corresponding angles, so that makes parallel lines here. A to B equals C to D. 16 to X needs to be the same thing as 15 to 18. We'll do this the quick way. We'll multiply 16 with 18 and then divide by 15. So 16 times 18 gives you 288, divide by 15, you get 19.2. Notice how we're getting a lot of decimals. That doesn't mean you're wrong. It's natural to be skeptical. You can always double check your work. 15 times 19.2. It's going to give you the same thing that 16 times 18 does. That's how you know you're right. Okay. The last problem here is a right triangle. We know that this is 8. That's the hypotenuse of the right triangle. This length here is a leg. We can find this length using our Pythagorean theorem if we wanted to. Now, using the other theorem, we would need congruent angles here. And we don't necessarily have that right now. I don't know that you can show that these angles are congruent. So using that theorem doesn't make a ton of sense. But what we could do is, since we have the hypotenuse, we could do the square root of 8 squared minus 4 square roots of 2 squared. That might look complicated, but it's actually kind of easy. 8 squared is 64. Now we'll come over here to the side. 4 square roots of 2 squared looks like this. We're going to multiply those two together. So you're going to take 4 times 4 to get 16. Square root of 2 times square root of 2 gives you 2. So you're going to do 16 times 2. Sixteen times 2 is not 64, it's 32. 64 minus 32 gives you 32. So your answer is the square root of 32, which doesn't make a lot of sense, but we're going to simplify this radically. It's going to be 4 square roots of 2 also. It'll be the same as this. So if these are the same, these are going to be the same when you have a right triangle.